So, anybody have questions? I worked out the first three. I worked them all out except for the very last two because the directions I put up, I couldn't figure out what the directions were for the last one. 26, anybody have questions on 26? What I did? 27, you're just going to write out your terms. If you're inserting 4 arithmetic terms, then obviously that's going to give you a to the 6. Negative 6 would be your a6. And then you plug in to find your d. 28, if you're inserting 3, then your last term becomes the 5th. If you're trying to find the indicated term, then you're going to plug in a 12. A to the 12th. When you solve for that 12th term, n becomes 12. This is your first term, and here you can figure out your d is you're going up by 3. And here your d is going to be negative 3, because that's what you need to get to the next term. 37, it asks you to figure out which term is 131, so in that case you're solving for the n. N is going to stand for what term it is, D is standing for your common difference, A1 is standing for your first term, and A to the n is what the term is for whatever the number n is. That's what term. Number 37? Okay, so it says in the arithmetic sequence -9, -2, 5, which term is 131? So I know that my first term is -9, and I know that my distance or my common difference between the two is going to be 7 because I'm going up 7 each time. If you have any two terms, if you even just have your first two terms, you can subtract them and find your common difference if you know it's arithmetic. And so then I just took my basic formula of a to the n equals a1 plus n minus 1 times d. And since I'm trying to find which term it is, I know this is my term, 131. And then I plugged in my a1, my first term, -9. I'm looking to figure out what term it is, the number of the term. So n has to be my variable that I'm solving for, Jacob. So I leave n minus 1, and then I know my common difference is 7. And then this is just algebra. It's however you want to solve for n. I subtracted 9 first, and then I distributed the 7, added 7, and then solved for n. Does that make sense? Okay, so you plug that in as you solve for the 131st term. Okay. Yeah, it says which term is 131, not what is the 131st term. A lot of people have said that they got the wrong answer here for these two problems. A lot of people said that they got one less, basically. They got 1,315, and then they got one whatever. The reason it has to be 21 and not 20, why you're finding term 21 and not 20. If you remember the very first time when we were looking, the very first day when we were working out problems and we found, we used the formula and we were going from like 3 to 7, and I said that you're going to find 3, 4, 5, 6, and 7. And I said you've got to be careful because you can't just do 3 minus or 7 minus 3 because that's going to give you 4. 3 to 7 is actually 5 terms because you've got to count term 3. If you do 1990 minus 1970, that gives you 20, but then you've got to add one more for the 1970 term. Right? Because if you count it up, it's 1970, 71, 72, 73, 74, 75, 76, 77, 78, 79, and then 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, and then 90 would be the 21st term. So you actually, if you subtract, you need one, you have to add one more to it. Does that make sense, Soraya? So, and the same with the business. If you do 1985 minus 1978, you get 7, but then you have to add one more to it to take into take the 1978 place, because that counts as a term as well. So that's why you needed one more. That's okay. That's why I wanted to go over them. The teacher guide was actually wrong on number 7 for the, as far, you all can see whether you agree with me or not. For the summation for number 6, when I added those all up, I got 95. Everybody agree with that one? For the summation, you didn't get 95? Okay, for the summation of number 7, I'm getting 31 and a half. You got 31 and a half? That's what you got, Justin? So I guess the teacher guide's just wrong. Everybody makes mistakes. The teacher guide said 30 and a half, but I'm getting 31 and a half. Because you've got an extra 1 from the 2 halves. Yes, sir. Where the 6 comes into play? You're going from the 4th term to the 6th term. So you are going, like in number 6, you're going to go from the 9th term to the 13th term. And then the 4th term to the 6th. This is where you start. The bottom of the sigma is the term you're going to start at. The top of the sigma is where you stop. No, you're never going to go down. You're always going to go. Nick, are you scaring people in the hallway? That was the famous last word. It wasn't me. All right. 11, 13, and 23, we're using this formula right here that our sum is n over 2 times a1 plus a to the n, or the number of terms divided by 2 times our first term plus our last term. Does that make sense? In the first one, the red one, number 11, I gave you the first term and the last term. So all you have to do is say that there are 10 terms divided by 2, and then we're going to multiply by 1 plus negative 20. The last term, a to the 10. Some will. There might be one that's that straightforward. And then like number 13, I wasn't as nice. Number 13, I gave you the first term, but you have to figure out what the 15th term is. But I gave you the common difference. So if you know that you have an arithmetic series, that it's an arithmetic sequence. So if you've got a first term of 73 and a D, or a common difference of 3, then you can use your arithmetic sequence of A1 plus n minus 1 times D. So you plug in 73 plus 15 minus 1 times negative 3, and then that'll be 14 times negative 3. So your 15th term is going to be 31, and then all you have to do is do 15 over 2, and then you've got 73 plus that 31 to get the 780. And this one, it says I'm going to find my first term to my 6th term, but my relationship is to find my first term, I do 1 minus 7. 1 minus 7 is negative 6. To find my 6th term, I plug 6 in here. 6 minus 7 is negative 1. And when I plug those two in, I'm finding the sum of my first 6 terms. 6 over 2 is 3. Negative 1 plus negative 6 is negative 7. And then that gives me negative 21. Okay? And then the last one, this one you would just use your algebra to find your arithmetic sequence. You just plug back into your A1 plus A to the n equals A1 plus n minus 1 times D. And so this would be 3 plus n minus 1, and what's my D? What is it going up by? 4. So that gives me 3 plus 4n minus 4. And is that 4n minus 1? Why, yes it is. And it says it wants the sum of the first 6 terms, so that's why we go from 1 to 6. And I think I gave you the wrong directions on number 37. You were supposed to find the first 3 terms of this sequence, so just ignore number 37. Don't worry about 37. Alright, so are we good? Good with everything that I gave you on arithmetic sequences? Yes? Peyton, you okay? Alright. Here? Well, if you wanted to find that sum, like if you wanted to actually find what the sum would be, if you want, well, this is just saying express it in sigma notation. So if you're just trying to express it, you know that the sigma tells us that we are finding the sum from 1 to 6. And then the relationship of this particular arithmetic sequence is 4n minus 1. If you wanted to actually find what the sum of the first 6 would be, then you would have to do the 6. That's where you would use your n over 2 times a1 plus a6. And then you would say, well, I've got 6 terms, so it's 6 over 2. If I plug the 1 in here, that would give me my first term. So 1, because 4 times 1 is 4, minus 1 is 3, right? And then if I plug a 6 in here, what's 6 times 4? 24. And 24 minus 1 would give me 23. So then you just do 3 plus 23 is 26. And then 26 times 3, I don't know. Somebody tell me what's 26 times 3? Who's got a calculator? 78. So that would be the sum of my first 6 terms.